A very warm good morning to everyone. Hope you all are doing good. We are again here, and I am Anjali Yadav, and it's my immense pleasure to welcome you all again. Thank you all for joining us yesterday, and the session was amazing. The Department of Computer Science and Engineering has organized a 2-day workshop on programming with Python hands-on for beginners in association with IEEE CS chapter, Esbitten Institute of Technology Management and Research. The convener of the workshop is Mr. Animesh Dayal, Head of the Department of Computer Science and Engineering and Information Technology and Chapter Advisor of IEEE CS Chapter. Our speaker for today's workshop is Mr. Ratnesh Chaudhari. Mr. Ratnesh Chaudhari is Assistant Professor of the Computer Science and Engineering Department. And the coordinator for the workshop is Ms. Roshni Talmali. She is Assistant Professor of Computer Science and Engineering Department. So we are here in the second day of workshop. So let's take a look over the syllabus of the 2-day workshop. So the topic for second day is libraries in Python, and there are various libraries which will be covered by the speaker. So without wasting much time, let's proceed further. I request Mr. Ratnesh Chaudhari to continue further. Thank you.
Good afternoon, everyone. Myself, Professor Ratnesh Chaudhary. I welcome you all in the second day of workshop on programming with Python, hands-on for the beginners. Today we are going to study the Numpy and Panda libraries and other libraries available in Python. So these are some important Python libraries which is available. Apart from this, Python has more than 200 modules that you can study, but we have listed here only few libraries which are mostly used and the popular libraries. The first library is a matplotlib, which is the most popular library used for data visualization. It is also used for drawing the various graphs, plots in Python. Second library is a Panda library, which is very fast and expressive library which has flexible data structure, and it allows us to work with tabular data, multi-dimensional data, homogeneous and heterogeneous data. We can do most of the data analysis using pandas. Then the next library is a request library which allows us to send HTTP request and also allow us to receive HTTP response. Apart from that, it is also capable of adding the headers, sending the form data and receiving the same. It also sends the multi-part files and parameters as per the requirement. The next library is a TensorFlow and scikit-learn, which is mostly used for machine learning. It also allows us to work with the various algorithms which is available in the machine learning. Another library is Numpy Library. It is also one of the most popular library which allows us to work with arrays. We can create any dimension arrays, we can change the shape of the arrays, we can modify the arrays, we can do the addition, subtraction and arithmetic operations on the arrays. We can analyze the arrays data based on their attributes and do a lot of operation in Numpy. Next library is Keras library, which is an ideal library for those who want to pursue their career in deep neural network. If you are a student of deep neural network, then you must go for this library. It is an effective library for such kind of student. Also, it is an open source library, so you can easily download it and use it. The next library is PyTorch, which is also an open source library used for machine learning, computer vision and natural language processing. The Scipy library is also an open source library used for scientific computation, technical computing, such as it contains a module in which you can work with linear algebra, integration, interpolation, and special functions like Fourier transformation. So you can do all these operations in Scipy library, specially designed for scientific and technical computation. Another library is Theano library, which is used for compiler optimization and compiler design. Scrappy is a library which has high-level screen scraping and web crawling facility. It allows you to do the screen scraping and web crawling in the way you want. It also performs data mining, monitoring, and automated testing. The next library is Pygame, which is mostly used for developing the games in Python, and the PyGTK library is mostly used for designing the graphical user interface in Python. The Opencv library is also a library provided for all. It means that it is also a open source library provided for computer vision. So if you want to pursue a career in computer vision, you should definitely learn this library Opencv. The last library is a PILO library, which is a subsection of PIA, and it is mostly used for image processing and do other kind of coding in the area of research. So these are some important libraries we have seen. Out of these libraries, in today's workshop we are going to see Numpy library and Pandas library in more detail. So what is a Numpy? Numpy is a Python library basically used for working with arrays. It also has functions for working in domain of linear algebra, Fourier transform, and matrices. It allows us to perform many operations on arrays such as transformation, creating arrays of zeros, arrays of ones, creating identity arrays, doing the transformation in the arrays, like finding the transpose of a matrix. All these operations are possible in arrays. Even you can sort the arrays and do addition, subtraction, multiplications of multiple arrays together. So all these facilities are provided in Numpy. It was created in 2005 by Travis Oliphant, and it is also an open source project. You can freely use it. The Numpy stands for Numerical Python. In short, it is called as Numpy. Now the question is that when we have a list, then why we are using the Python? The answer is very simple. List is very much slower as compared to the NumPy, because NumPy is 50 times faster than the traditional Python list. Okay, why it is slower? Why it is NumPy is faster, and why the list is slower? The answer is that NumPy store the data in contiguous memory location. So whenever we need to access the data, it can be accessed easily and efficiently by the CPU. However, list does not store the data in contiguous memory location, and that's why it is not much efficient and it is slower. Now let us see how to do installation of NumPy. Suppose you are using the if you have already Python installed on your system and you are having a pip file installed on your system, then you can install the NumPy by simply going into Windows command prompt, and there you can type the command pip space install space NumPy. If you are using the Mac operating system or Linux operating system, then you can go to their respective terminal and type this command pip space install space NumPy, and your NumPy will be installed automatically. First it will be downloaded and then it will be installed automatically. If you are not using the simple Python, if you are using the Python distribution such as Anaconda, then you can use the following command to install the NumPy. The command is conda space install space NumPy. You have to go into Anaconda command prompt and there you can type this command. Let me show you how to do these things. Okay. So here, suppose you are working with Python and pip, so you can simply type here cmd and the command prompt will appear in front of you if you are working in the Windows. Okay, and here you can type your command pip space install space numpy and press enter, then it will automatically start installing. Okay, it will first be downloaded, then installed automatically. I have already installed in my system, so I will not waste time on it. Okay, suppose if you are using the Python distribution such as Anaconda Navigator, then in that case you can simply search here Anaconda, and here you can find the Anaconda prompt. Okay, there you can type your command. Once it is started, just wait for it. Working with Anaconda is very easy, and we should work on this because it is the latest Python distribution. It allows us to have multiple libraries simultaneously. It also provides the Jupyter notebook in which we are going to do the rest of our coding in today's session. Why to use Jupyter notebook? Because it is much faster and easy to work, and also it is the latest notebook which we are using. The most of the industry people are using this Anaconda public distribution which comes with the Jupyter notebook. So if you want to install the Anaconda Navigator, you can simply go into the Google and do the searching like Python Anaconda, and you will find that the software is freely available. You can download it and install it on your system. It will take a time to install. It will take around 10 to 15 minutes to install, and after that you will see these icons will appear in your search box, and from there you can start Anaconda prompt to install the numpy. Once the numpy is installed, okay, for example, let me show you. I am typing Panda install numpy. Okay, I have already installed, but still I can show you. So I have pressed this command, so it will be downloaded automatically, and it will be automatically installed in your Anaconda public distribution. Now let me show you how the Anaconda works, okay, and how to do coding in the Jupyter. So if you want to work in Jupyter, you have to first start Anaconda. I have already installed it. If you want to download it, you can just do the Google search and you will be able to download it. We are using Anaconda because most of the libraries we don't need to import, such as suppose we want to work in the Pandas. So Panda is already there in the Anaconda. You don't have to install it externally. Okay, that's why we are referring this latest Python distribution, which is called as Anaconda. So you can type here Anaconda and Python. That's it. So here you can see individual edition Anaconda. You just have to go there and you can install the product from here. So individual version is for the individual people. If you are organization, you can use the other versions also there. Okay. Here you can simply download it from here for your Windows. Okay. If you are using some other operating system, we have options here. You can click on that and you can install it. Okay. So this is the website anaconda.com to download the Anaconda Python distribution. The Anaconda support most of the libraries of the Python, which is latest libraries such as Python, such as Pandas, Numpy, etc. Okay, that's why we are using the Anaconda. That is the main reason. As you can see here, when I type the command conda space install numpy, so it is collecting package metadata and later on it will be automatically installed. Okay, it will take some time. Well, I have already installed it on my system, so I don't have to wait for it. Okay, in the last it will say that it is automatically installed. Already it will say that it is already installed because we have already installed it. Okay, now let me show you how to work in the Anaconda and Jupyter. So first of all, start the Anaconda Navigator from here. So this shows your installation of NumPy in Anaconda, and this is what Anaconda starting. Okay, so automatically a lot of SQL file will run. Anaconda is a huge software because it supports a lot of the editors, and it also has a lot of libraries along with it. So it is saying that all requested package already installed, as you can see here. Okay, because we have already NumPy installed in my system. Now let us wait until the Anaconda starts, and once the Anaconda will start, then we will be able to start the Jupyter. Okay, because Jupyter is in Anaconda. Okay, so as you can see here, when the Anaconda will start loading, it will show this particular circle here. This is a symbol for Anaconda. It is being uh, activated. Okay, now it is opening. Let us wait for that. It's a new software, so it takes some time to start. But once it is started, you can easily work on it without any problem. Yes, now it has opened. You can see here, this is our Anaconda Navigator. Okay, in this Anaconda Navigator, you have to go to the home, and there you will find the Jupyter. Okay, just click on the Jupyter and it will be automatically launched. Okay, by default, the Jupyter will be launched in a web browser. Okay, so my default web browser is a Chrome. Okay, it will be open in that. Okay, just wait for a few seconds and then it will be automatically launched in the web browser. So as you can see that the our Jupyter has started. Okay, I launched twice, so it is twice. Okay, so we need only one page, so I'll close the other page. So you can see here, this is the home page of Jupyter. Okay, and if you want to work in the Jupyter, okay, on the left hand side you can see number of files are there and number of folders are there. These folders belongs to your computer system. Okay, and if you want to do the coding in Python, just click here, take a new file, new, and then Python 3, start it. So these are the available resources in your system. These are the folders from where, these are directory from where you can access the data. If you have previously stored any files or any Python program, you can access it directly and open it in the Jupyter. Okay. So you can see Jupyter notebook has been started. Okay. I want to create a new file. So new file has been started, Untitled 11. You can rename it by your name as you wish. So I can give any name, like I'm giving ABC, or simply give Python, Numpy. Okay, rename it. Okay. Now you can see, this is the box where you have to write the code. Okay, after writing the code, just press Shift Enter, and the code will be executed. Okay, so let me show you. Print writing hello, suppose. So you are getting the output immediately. Okay, this is how we have to work in the Jupyter. Okay. Now let us try to. You can run it by pressing Shift Enter, or you can just simply click here on to run and it will run. Okay. Now let us start the working with Numpy array. So let us start how to import Numpy. So I am writing import Numpy. And then you can create the array using the Numpy. So I'm just creating an array. ARR is equal to Numpy dot array, and I'm passing one list here in the array, and then you can simply print this array ARR. So you can see here we have successfully created an array using a Numpy. Okay, we can also import the Numpy as any other name. So I'm importing Numpy as alias name. Okay, so alias name I'm keeping as NP. So alias name is a name given to any library or any class. Okay, so I'm giving alias name NP to NumPy. So whenever I'm referring NumPy, I can simply write NP. Okay, so here I'm going to import NumPy as NP, then creating the array ARR equal to NumPy, and this time we'll try to create the NumPy array using tuple. Okay, so I will write NumPy NP. In place of NumPy, I am writing NP because NP is nothing but NumPy. Okay, because of alias name. So NP dot array function we can use to create the array. This time we are passing a tuple. Okay, suppose we are giving 3 elements here. Okay, and then we can print AR. Okay, so you can see in the output we got the array. Okay, this is how we can create the array. You can create the array by directly passing the list, or you can create the array by passing the tuple, or you can create the array by defining the list earlier and then passing it here. Suppose I want to create a tuple T or list L, and I'm keeping some item there, 1, 2, 3. Okay, and this time I'm passing the list L as an argument here. Okay, so again you can see I'm running it again, so I'm getting the same output. So first we created the list, then we created the array, okay, from the list using NumPy. So everything is possible. You can either create the list or tuple or any other sequence, and from that you can create the array easily. Okay. Now let us talk about how to check the data type, okay, of the array. So if you want to check the data type of array, then you can simply use the function type. So I'm writing print type and then printing the type of AR. So you can see here it's a NumPy ND array, it's a NumPy n dimensional array. Okay. Now if you want to check the data type of the elements which are there in the array and the size of the array and the shape of the array, then you can simply do that using the properties such as dtype, size and shape. Okay. So here I am willing to know the data type of the elements which are there. So I can simply write print and then arr dtype, okay. And you can see that it's an integer 32 bit. Okay. Then I am printing the size. Size means what? Number of elements in the array. So currently we are having 3 elements. So printing the size arr dot size. So you can see size is 3 element, number of element is size, and then shape is your dimension of the array. Okay, so arr dot shape. So we have 3 attributes: dtype, size and shape, through which we can know about the array. So you can see that it's a one dimensional array having 3 elements, okay, in the side. Now let us try to create a different dimension array. Till now we have created only one dimension array. Suppose we want to create a 2-dimensional array. So you can simply write 2D is equal to np dot array, and you can pass a list of lists from here. So 1, 2, 3, comma 4, 5, 6, like that. Okay, and we print it, print 2D. You can see that it's a 2-dimensional array because it has 2 opening square bracket and 2 closing square bracket. 2 number of rows is here, first row, second row, 3 columns is here, so 2 by 3. Suppose you want to know the shape, you can simply print arr dot shape. Now similarly, if you want to create a 3D table, you can also do that. Okay, just you have to increase the bracket here. Suppose increasing the bracket here. Okay. You can add the number of elements you want to add. So this 3D array will contain 2 2D arrays. So let me show you. So you can see that we have 3D array in which this is first 2D array, okay, and this is our second 2D array. and both are contained in a array. That's why it is a query array. Okay. Now let us talk about how to create arrays full of zeros. Okay. So if you want to create arrays full of zeros, then the Python provide a function called zeros. Using that, you can create array full of zeros. Okay. So it has a syntax which provides a shape, data type, and order. So zeros has three parameters. First one is shape, second one is data type, and third one is the order. Okay. So I am using the zeros function now to create an array of zeros. Okay. So I am writing a equal to np dot zeros, and I am passing a value 2 here and printing a. So you can see here we have the array which contains two number of zeros. Okay, because we are passing 2 here. Okay, so we can change it. We can pass 10. So we'll have 10 elements in the output. As you can see. Suppose we want to create a multi-dimensional array of zeros. That also we can do easily. Just you have to pass the dimensions in square bracket from here. For example, now I am passing a dimension 2 comma 2 or 5 comma 5, suppose. Okay, so you can see here we have a 5 by 5 table of zeros. Simply giving the 5 and 5 here will create a 5 by 5 matrix of zeros. Now suppose you want to create the array of ones, then you can simply use a function of ones. Okay, it is similar to your zeros function. Okay, I can print a. Suppose you don't want a floating point value in the output, either in zeros function or ones function, then you can simply mention a second parameter t type here and mention it's an integer. Then you can see that we are getting 1 1 1, which is of type integer. Okay. Suppose you want to create an identity matrix, then you can use a function eye function you can use. So let me show you that. So for that you can simply write you can use this code. Okay, and you can write here in place of ones you can write eye. Let me show you some other example. So b equal to np dot ones, and now we are passing. Yes, let me show you. We are talking about I function. So I. So you can see there's identity matrix, okay, of size 2 by 2. Similarly, if you want to create identity matrix of size 5 by size, simply pass 5 and you will have the identity matrix 5. Okay. Now sometimes it is the requirement of user to not only use ones and zeros or identity matrix, but sometimes we want an array full of a particular given number or any number of choice as per the choice of the user. Okay? So that also we can do. So for that we can use the function called full. Okay, and we create C np.full. It has 4 parameters. First one is shape, second one is a field value, and third one is a data type, and the last one is a order. Okay. But frequently only 3 parameters are used. Okay, so I'm writing np.full, and I want to create an array of size 2 by 2. Okay, suppose create 5 by 5, suppose 5 by 5. Now I want to fill this 5 by 5 matrices with a value 99. So I'm putting the value 99 here, and then I'm taking the data type d type as integer. So it will create a 2-dimensional matrix filled with value 99. Okay, this matrix will be of size 5 by 5. So you can see here the output. Suppose you don't want to put 99, you want to put 101. Change it. You don't want integer, you want something else. You can mention that as per your need, whatever you want, you can mention. You want to change the size, you can change it 2 by 3, like that. It is very useful to create an array of random numbers in many of the applications, especially in data science, pandas. Okay. So suppose we want to generate an array of random numbers. Okay. So how we can do that? Okay. For that we have 2 functions mostly used in Python. First one is a randint, which generates a random integer, and the second one is rand function, which generates a floating point number. Okay. So in Python, if you want to work with random numbers in Numpy, then you have to import a module called random. Okay, and from there you can import the functions which whatever you want. So in order to import the functions from the random module, you can simply write from numpy import random. So we are importing a random module here, okay, from numpy, and then we can use the randint function. So I'm writing x equal to random dot randint. Okay. The randint function will give you the random integer number, okay, in between the given size. So I'm writing a 100. So it will give you a random integer number under 100. Okay, and you can define the size here. Okay, size equal to 5, and then print x. Okay, so you can see here we are getting a random integer number using this random function, which is imported from the random library, random module, and which is there in the numpy. Okay, so from numpy we are importing random, and from random we are using this random function, which is we are passing two arguments here. First one is 100. Okay, which is telling that you have to take the random number from 0 to 100. Okay, and this size 5 is telling that take 5 numbers. Okay, so now suppose taking 10 numbers, then what will happen? Yes, we are getting 10 outputs. Okay, 10 random integer numbers in between 0 to 100. So like this we can generate a random number. Suppose you want to generate a random float number, so in place of randint you can simply use rand function. Okay, so rand function provide random float number in between 0 to 1. Okay, so let me show you that. So again you can import from we have already imported, so don't need to import again and again. So we can write simply x equal to random dot rand. Okay, and we can print X. So you can see here it generates one random number by default, which is in between 0 and 1, and it's a floating point number. Suppose we want more than one random number, so we can mention here. So I have mentioned 2, so I am getting 2 random number in between 0 and 1. I want 10, you can mention 10 like that. Okay. Suppose you have an array which is predefined, like suppose let me create one array. Suppose you have one array and you want to select a random number from that array and print that number. That also can be easily performed in Numpy. So let me show you that how to do this. Suppose x equal to random dot choice. Okay. Now what I am doing is I am trying to create one array here with these values 3, 5, 7, 9. Okay. Yes. And using this list, I am picking one random number. Okay. So if you want to pick a random number from an array or list, you can use choice function, which is available in the random module of Numpy library. Okay. Print the random number. So it has taken 5. You can see 5 is there. Again, if you run it, next time it is taking 7. So it is the quality of this function that every time you run it, it will give you different output, random outputs. So 3 times I have run it, I am getting twice 7. This time I am getting 3. Okay, again let us try to run it, getting 9. Okay. So every time you run it, you get the random numbers. The numbers are not always same. That is the benefit of this random module. Okay. Now suppose you want to access the elements from the Numpy array. So you can simply do that by using the index values. Okay. You can also perform the slicing onto the array using index values. Okay. You just have to mention the starting index value and ending index value. Okay. So let me show you that how to access the elements from the array. Suppose I have one array x equal to np.range, and here I am passing 5 suppose, and then printing. So arrange function is a function which is help us to create an array which have the value less than whatever we have mentioned in the argument. So I have mentioned 5. So it will create an one dimensional array having value less than 5. So suppose we provide here 10, so it will work for 10. Okay. So we provide you 0 to 9 values. Now suppose I want to access one of the element from the x, you can simply do that. So print. Suppose I want to access this element 2. Okay. So I can simply write the index value in the square bracket. What is the index value of 2? Is 2. So we simply print it. Okay. Yes. X of 2 is giving 2. Let us take another array, for example, x equal to np.array, and if you pass some different values like 10, 20, 30, 40, like that. And now I want to print this x. Yes, 10, 20, 30, 40. Now I want to print a certain element, a particular element from this array. So I can simply write the array name, then the index number. So suppose I want to print 20, so the index number 20 is 1, so I can write 1. So like this we can access the element. Suppose we want to slice this array. We want the array which is having the element from 20 onwards. So you can simply like print x, and here you can mention the start index and end index and colon in between. Okay, so I am providing starting index of 20 is 1 colon. After colon you can mention the n index value. Okay, so 1, 2, 3. So 3 is our index value. So whatever the element you want, you have to provide the index value 1 more than that. So suppose I want this element to include in the output, so I have to provide here 4. Okay, because by default it will take 1 less than that. Okay, so this is output. Suppose you want to print the same thing. Okay, and you do not want to give the end value, that is also fine, because by default it will go up to the last element and it will print the element. Okay. Suppose you want to print the whole array, then how do we do it? We can simply do it by providing the name of the array. So you can see here we have 4 elements. Same thing can be done by giving the index value also, giving the starting index value and the last index value. You can see the same output is there. Okay, let me show you one more time here. Yes. So simply printing x or printing x with this start index value and end index value will give you the same result. If you ignore the index value, by default it will go up to the last element. Okay. Suppose you provided the end value but you ignored the initial value, still it will by default start from 0. So it will give you same output. Suppose you forgot both the things starting and ending, still it will give you same output. Let me show you that. Run it separately. Yes, we are getting the same output. Okay, so by default the starting index will be taken as 0, and by default the end index value will be the index value of the last element plus 1. Okay, it will cover the whole element simply. Okay. Suppose you want to print the last element 40, but you don't want to use the forward index value, positive index value, so you can also use the negative indexing here. So how can I use the negative indexing? So in the reverse direction, if you do the indexing of this array, the first element is having the index value as a -1, so you can simply write x of -1. Okay, it will give you the first element of the array from the right hand side. Let's see. Similarly, if you want the second element, -2 from the right hand side, second element, first 40, second is like this. So negative indexing can also be used for slicing as well as for accessing the elements in the array. Suppose you have a two-dimensional array and you want to access the element from there, so that also can be done. So let me create one array of two dimension. I think we have one array of two dimension. Do we have array of two dimension? No, it is of one dimension only. So let me replace it to create a new array. Suppose this is our new array, okay, of two dimensions. So you can see it's a two-dimensional array. Now if I want to access a certain element, suppose I want to access this 5, I want to print this 5 out of this array, then how can I do that? So you can simply use the indexing. Okay, so you have to just write print and then name of array, and after that you can simply write the index value. So here two index value will be required. One index value will be required for the row, and one index value will be required for the column. So suppose I want to print this 5, so row number 2 is there, second row is there, so the index value of second row is 1, okay. Index value of the first row is 0, second row is 1, okay. So I am providing 1. Then here again inside this particular row I have to go to the second element, so again the another index value will be 0 and then 1. 1 will be another index value. So like this you can access the element. Suppose I want 6, so I can simply change. Okay, like this. Suppose I want to print 3, then how I can do that? So first I have to select the first row. To select the first row I can give the index values 0. And from the first row I want suppose third element, so index value of third element is 0, 1 and 2. So 0, 2, that's it. You give it 3. Like this we can access the element in 2D array. Similarly for 3D array also. You can access the element. Only we have to provide 3 indexes there. So the first will be the first will identify the 2D matrix. Second will be the row. Second will identify the row of the particular 2D matrix inside the 3D matrix, and the last element will identify the column number. Like this is important. Now let us see how to add an element, okay, in an Numpy array. So for that let me create one array. Here are one np.arrange. Using arrange function to create a one-dimensional array to certain value. So printing. So this is what the array we have. Here are one. Okay. I want to add some element here. So I can use two functions. Either we can use append or we can use insert function. So first let me try the append function. So here are one is equal to np dot sorry. You can store the result into another array. So here 2 is equal to np dot append. Okay, and then you can pass the source array. So source array is AR1 in which I want to insert the element, and then you can pass the element that you want to insert. Now try to print AR. So you can see here element has been inserted. Element has been inserted. So this is how the append function works. Append function will add the element in the last of the source. Okay, so source is having the last element 4. After that the new element will be added if you use the append. If you want to insert the element somewhere in the middle, you can use the insert function. So in place of append, you can use insert, and here you can pass the first argument as an array name, and then the index value where you want to insert the element, okay, and then the value that you want to insert. Suppose I want to insert 999 at index 2 in ARR1, then I can write like this. So let us execute it, print it again. So you can see that 999 has been inserted. So in ARR1 at index number 2, insert 999. 0, 1, 2. At index number 2, 999 has been inserted. So this is how we can add element in array. If you want to remove the element from the array, you can simply use the delete function available in Numpy. Okay. So how to use a delete function? Simply you can write any array name. Suppose I am taking x is equal to np dot delete, and you can pass the array. Suppose in ARR2 I want to delete 999, so I can pass ARR2. Here I want to remove 999, and I can pass the 999. Is showing the error. If you check that error, index error. So successfully deleted 0. Okay. Now let us try for this 999. That is working, showing the same error again. It is showing the error. Okay. Indexing error. So basically, let me show you why it is showing the error. It is working on the index value rather than on the object value. Okay, so I can give the index value of 999. Okay, but before that, let me print the array and let us see how it is looking like. Print AR2. Yes, AR2. So you can see here, these are the elements in AR2. Now I want to delete it, so I am using p is equal to np dot delete. Okay, and here I am passing the AR2 as a first argument, and then you can pass the b. So as I am passing 3 here, okay, you can see the element 2 has been removed. Okay, so check out the index value of 2, 0, 1, 2, and 3. So when you pass, if you want to delete any data from the existing array, you can simply write the array name and index value. Then it will delete the element whatever you want to delete. Okay. So it does not require the value here. It requires the index number. Okay. Whose which element you want, you have to provide the index number of that element. Okay. Then let us see the some of the slicing operation of the array, okay, which we have covered earlier also, but let us see them. Okay. So we print p again here. So these are the element in p, and suppose I want to print this 2 value only. So I want to slice it. So I will print. What can be the index value? Can you guess? So I think it should be. So index value 0, index value 1. So 1 colon 3. And if you write this, it will take by default 2 only. So it will go up to here. So it will print 1 and 99 is out. So this is how we can do the slice. There are some rules of slicing that we have to understand. Okay. In slicing, we can also define the steps. For example, suppose I want to print all the elements, so I will write 0, 1, 2, 3, 4, that is the index value 5. So I want to print all the elements, I have printed all the elements 1 to 5, or start from 0 to 5. Printed all the elements. Now suppose I want to take a step. Suppose I want to take the first element and ignore the second, print the third, and ignore the fourth, like that. Alternate element I want to print. So that also I can measure by giving the colon again. Okay, so let's try that. So here I am giving 1. That's why it is taking all the values. Suppose give 2. And see, it is taking the alternative element. So this is showing the starting index value. This is showing the end index value, and this is showing the step value. That by how much value you have to jump. So it is jumping by 2 values. So it will take this and then go to next second value, this, then this, like that. So it will print the alternate element. Okay. Now let us talk about the copying operation and viewing operation. We can simply copy the array, one numpy array into another array by using the copy function. Okay. If you use the copy function, then what will happen? A new memory will be allocated to your copy, and if you do any modification in your copy, then original data will not be lost. Okay. But if you are viewing the data, if you are not copying, only creating a view of your data, and if you are modifying the view, then the original data will also be modified. Okay. Let me show you the difference between view operation and copy operation in NumPy array. So take an example. ARR is equal to np dot array. Creating one array just for the operation 1, 2, 3, 4, and 5. Then trying to copy this array ARR into another array called X. Okay. Now it has been copied. Now I'm trying to modify this X. So I'm modifying the first element in X and giving the new value 42. And after that, let us try to print the effect on the original as well as on the copy data. So this is the copy data X. Just print that. So you can see that after modifying the copy, okay, copy stored in X. Okay, now I'm modifying the X. So after modifying the X, still the original data is not modified. It is added because we are using the copy operation. We are doing the copy operation. So copy method does not affect the original data. Okay, if you modify the copy, it will not affect the original data. Now let us try to do the same operation. Okay, but this time we are using the view function. View. Okay. So you can see here, whenever I am using a view function, okay, then the original data as well as your copy data, copy copied array, both are modified. So when I am modifying the view, okay, your original data is also modified. So that is the difference between copy and view. Now suppose we have an array of a particular size, 2 dimension. I want to convert it into 1 dimension, or I have an array of 1 dimension and I want to convert it into another dimension like 3 by 3 or 4 by 4 or 2 by 3 like that. So that operation is called reshaping of array, and in NumPy we have a function called reshape that allow us to reshape any array. Okay. So first of all, focus on our this array ARR and find out the shape of this array. Okay, what is the actual shape of this array? For that we can simply use the attribute shape. Okay. So you can see that 5 elements are there and this is the shape of the array. It's a 1 dimension having 5 elements. Now creating one array having same name, but this time I am defining it as 2 dimensional, putting some element in it, 1, 2, 3, and then 4, 5, 6. This array has been created. Now I am trying to print the shape. So I am using ARR dot shape. So there has been a mistake while creation. So just write that 2 dimensional array, so 2 bracket must be there. So you can see here we have shape of this particular array. It's 2D array. You can print it for calculation. So this is our array, two-dimensional array, okay, and this is the shape, 2 by 2. Shape will return you the exact dimension of any array. So it is possible in NumPy to change the shape of any existing array. Okay, that operation is called as reshaping of array. That operation is called as a reshaping. Okay, so how to do that reshaping? Okay, for that we have a function called reshape in Python. Okay. While doing the coding, if you want to save your work, you can simply click on File and press Save and Checkpoint. Okay, it will save in a directory, or you can simply press Ctrl S. Now, let me show you how to do the reshape operation. So, P equal to np dot reshape. Okay, P is our temporary array, and we are trying to reshape the ARR here, the existing array ARR. Okay, so it has the element 3 and 3. Total 6 element is there. So 2 by 3 is possible. Okay. 4 by 2 is not possible. If I do 4 by 2, I will get the error. Why we are getting the error? Because 4 into 2 that requires 8 elements, and here we are having only 6 elements. So it should match with the number of elements, otherwise we will get a type error, value error. Okay. So let me match it. So 2 by 3 can be converted into 3 by 2. So now it is no problem. You can print it. Print P, and you can see the shape has been changed. So earlier in each row we were having 3 elements, now in each row we are having 2 elements. Earlier we are having 2 rows, now we are having 3 rows. So this is how we can reshape. The only requirement is that the number of elements should match with the shape. Okay. Suppose you have a 3-dimensional array or n-dimensional array, and you want to convert that array into a 1-dimensional array. So that is also possible. Okay. How we can do that? So that can be done with the help of again reshape function. You have to simply pass a -1 parameter, -1 as an argument. Okay, let me show you that. Suppose I pass here -1. Okay, then the this complete 2D array will be converted automatically into 1D array. Okay, you can see here. This is called flattening of arrays. This is called flattening of arrays in Python. So if you want to flatten any array of any size of n dimension, you want to convert it into 1 dimension, you just call the reshape function, pass -1 as an argument, and it will give you a 1-dimensional array having all elements in the previous array. Okay. Suppose you want to print the elements in this particular array P. Okay. So you can simply use a for loop for that, and with the help of for loop you can print the element in array. Suppose you want to print the elements of 2-dimensional array. Okay, in that case also you can simply use the for loop for x in ARR, that is the name of array. Okay, and then print x. But this time it is printing one row at a time. This is printing one row at a time. It is not printing every element one by one. So if you are using 2-dimensional array, then it will take 1 dimension at a time. If you are using 3-dimensional array, then it will print 2D array at a time, one 2D array at a time. Okay, one 2-dimensional array at a time. Okay, so let me clarify it. Suppose you want to print a 2D array element wise, then you should apply 2 for loops. So like for y in x. Okay, and then you can write print y. So now you can see that we have each element printed from this 2D array. Suppose you have 3D array and you want to print each element, you can simply use 3 inverse. Okay. This operation is called iterating the Numpy array or printing the elements of array in Numpy. Okay. Let us have a look on Numpy joining array, how to join an array in Numpy. So let us create few arrays, np.array 1, 2, 3, and similarly one more array we can create two second array which will have some different elements for 5, 6, let us put 4, let's take 10, 20 and 30. Two arrays here, and if I want to join them, if I want to concatenate them, then I can simply use a function concatenate. Okay, so I am joining them in third array. Here 3 is equal to np dot concatenate, and I am passing both the arrays as a parameter. Print. So as a result, you can see that here we are successfully able to concatenate these two arrays. Okay, let me print the previous array so that it will be very clear to us. So earlier the AR1 looked like this, AR2 looked like this. After joining into AR3, okay, the array is looking like this. Okay, it is looking like. So it is possible to concatenate two arrays in Numpy by simply using concatenate function. Okay. If you want to split the array in Numpy, that is also possible. Splitting is a reverse operation of joining. Let me show you the example. And when creating one array, np dot array, put some element in it. 1, 2, 3, 4. Suppose 4 element. And I want to split it, so I will write new array is equal to np dot array underscore split, and then I can use name of array. Okay. I want to split it into 3 different arrays. So now print new array. You can see here we have executed. Okay. Rest of the part of Numpy and Panda we'll see in the next section. So in the previous section we have seen how to join the Numpy arrays and how to split them. Let us take one more example on that. Suppose we have an array called A and create one array using some tuple 5, 4, 9. Print this array. We have to import it one more time because we have restarted the notebook. there is no problem. Let us import it. Import numpy as np. So here you can see the array has been created. Let's create one more array called b dot array, and this time we are passing some other values like 10, 20, and then printing the b. So you can see we have created two arrays a and b. Now let us join them together using the concatenate function. Okay, so create another array c and np dot concatenate a comma b. So we need to pass these arrays as a tuple. Okay. And you can see the result after joining. Okay. So these two array has been joined here. Okay. Now let us see the other operation which is called splitting the array. Suppose we have one array called C here and we want to split it. So we can simply split it and create one new array np dot array underscore split. This function we can use to split the array. We want to split the array C into two parts. Suppose. So I am passing C as a source array and to indicate number of parts we want and how many parts we want to split it. That 2 is indicated. Okay, 2 is indicating we want to split it into two parts. Okay. Now try to print t. So you can see we have to split this array into two parts. Okay. What happens if you split it into number of parts? Okay, which is like suppose splitting into three parts. So you can see the result. So it equally divides the number of elements. Suppose it has 6 elements, so 2, 2, 2 is equal division. Okay, so in each array, 2 elements is there. Okay. Suppose I want 4 split, then what will happen? It has 6 elements. So some array will contain 2 elements, some will contain 1 element. Like this. Okay. The next operation is searching the arrays. Okay. Let us try to search some array. So let's create one array. C is already with us. Print it once again. Yeah, C is there, and now we want to search the array. Okay. So I can perform searching by giving the element values. Okay. So let me show you how to search it. Okay. So I'm just writing here k equal to np dot where. So where function is basically used for searching. Okay. So you can write np dot where and then you can pass the element which you want to search. Okay. So I'm writing C is equal to 10. Suppose I want to search for C. Where is C? Okay, that I want to search. Okay. And then print. So it is showing where the element is. It is at the index number 3. Okay. 0, 1, 2, and 3. And it is also showing a data type which is integer 32 bit. Okay. So like this it returns the result. Okay. Suppose we want to search the element 4, you change it, you can see the index value is 1. So in this way we can perform the searching in arrays. Okay. Now if you want to sort the arrays, okay, you can also do that. So suppose I want to sort it. Suppose create one array with random numbers like z is equal to let's say z equal to np dot array and create one array 3, 2, 9, 0, 10. Suppose element is like this in the array. So we are creating a new array which has the unsorted data and we want to perform sorting on that data on that array. So in order to perform the sorting, you can simply use a function called sort, which is available in Numpy Library. Okay, simply you can say print np dot sort, and you can pass the array name which you want to sort. So you can see that array has been sorted and it has value 0, 2, 3, 10 and 99. Okay, like this we can perform the okay. Now the next topic is filter array in Numpy. So filter arrays are those arrays which has some special value. Suppose you have given an array and from that array you want to filter out some data. You want to take out only some particular data and leave the rest of the data. That kind of array is called filtered array, and you can create a filtered array, okay, easily by using the boolean values. Okay, so we need to first create a list of boolean values which will indicate that which element we want to take out from the array and which element we don't want to take out from the array, and these boolean values corresponds to the index of the elements in the array. So let us clarify it with an example. So creating an array arr is equal to np dot array and then passing the values 31, 42, 33 and 34. So new array again we are creating, and now I am creating a list of booleans, okay, which will have the value true, true, false, true. So here I have given a false value for the third element. So this element will not be included in the output and it will be filtered out. It will be filtered out. Okay. Now let us create a filtered array. So z is equal to arr of x. So here we are passing x, which is the name of this particular list, boolean list, and according to this boolean values, okay, the array will be filtered out. So for that, first print this array so that we can see it in the output, okay, and after that print it the filtered array z. You can see that initially it has four values 41, 42, 43, 44, and initially the list has true, true, false and true. So where we got false at the 43. Okay, this value corresponds to this particular element. Okay, so that's why this element will be filtered out, and in the output we don't have that value. So in this way we can simply create a list of booleans, and using that we can create a filtered array from the existing array. Apart from this, we have a lot of operations in the array that we can perform, like we can perform the addition of two matrices, subtraction, multiplication of the elements. Like that we can perform a lot of operation in the array. Okay, you can perform the reverse of the array. So these operations are there, you can try it at your own. Okay, now let us begin the another library which is called Pandas in Python. Hello everyone, now we are going to see the other library in today's topic, which is Pandas. Panda is a Python library used for working with data sets. It has function for analyzing, cleaning, exploring and manipulating data. Panda is very much useful when you are working with data sets, Csv file, JSON files, You want to analyze the data in the data sets, and accordingly you come to a conclusion. Okay, then you can use pandas. Okay, Panda allows us to create day series, data frames, work with time series, and other data of homogeneous as well as heterogeneous types. To work in pandas, we can simply use this new file which I have taken right now and rename it as my pandas one. So what we can do in pandas, we can find the maximum values, minimum values, average values in a particular rows, particular column. You can find the correlation between rows and columns. We can delete the rows which are not necessary or not relevant to us. We can find out the empty cells in data sets. We can clean the data sets. All this operation can be done easily in Panda, and that's why Panda is very much popular. If you are looking for a career in data science and machine learning, then you must know the Pandas library and how to use it. Now let us see how to install Pandas on your system. If you want to install Pandas on your system and you have already Python and pip installed on your system, then you can simply type the command pip install pandas. This command you have to type in your command prompt. For example, I am using Windows, so I can go to Windows command processor and I can type this command pip install pandas. If you are using Python and pip, then you have to write this command. You can install it. If you are using the operating system other than Windows, then for example, suppose you are using Linux, then you can go to the terminal and type the same command. If you are having the Python distribution such as Anaconda, then you do not need to type this command. Okay, the Anaconda has already pandas along with it, so in that case you don't need to install the Panda separately. Okay. In my case, I am using the Anaconda, which is a Python distribution. So I'm not going to install it again. Okay, this is for your reference. Okay, if you want to install, you can install it. Otherwise, if you're using Anaconda, then don't worry about it. It is already there. Now let us see how to import pandas. So if you want to import pandas, you can simply write import pandas and run it. Okay. You can also import pandas as alias name. So I can give any alias name. Okay, so I'm giving PD. So I'm putting pandas as PD. Okay. So whenever I refer to PD, it means that I'm referring to pandas. Okay, because PD is another name for pandas in my program. Okay, alias names are alternative name to refer to the same thing. Okay, so in place of pandas, I can write PD. The first topic in Panda which we are going to learn is series and how to work on the series. Then we'll look for the data frames and the other topics. So what is a series? Series is like a column in a table. If you want to work on the data which is in the column format or like the one dimensional array format, then you can use the series. Okay. So series nothing but you can say it's a one dimensional array holding data of any type. Okay. So let me show you how to create a series. If you want to create a series, first you need to import Panda. So I have already imported it, so I can simply use it. Then create a list. So a list has been created, and then you can create the series s equal to pd dot series. Series function is used to create the series, and you will pass your list here. Okay, and then you print the series. So I'm printing the series here. The creation. In the series, you can observe it. On the left hand side, we have the indexes 0, 1, 2, 0, 1, 2. These are called labels in the series, and 173 is data. 173 is a data, and 0, 1, 2 is a labels. Okay, and this tells the category of your data. So I'm having integer 64 with data here. Okay, now let us see how to access the series using the default labels. Okay, so here just now we have seen how to create a series in pandas. Okay, so here we are using the default indexes because we have not provided any indexes or labels. So by default some indexes are taken, and this is by default 0, 1, 2. Just like the array, normal array, the default indexes are starting from 0 here. Okay, but if you want to define your own labels or index, then you can do that easily in your series. Okay, we'll see that how to do that, but before that let us see how to access the element in the series. Suppose I want to access this value 7 or 1, then how to access those values? So let me show you that. First of all, we need to create a series. So we have already created a series. So just take that example. Okay, and in that example I can access a series. So I'm not printing a series. Let us access the element of the series. Okay. So as you can see here, I have passed the labels or index value 0 of the series, and I'm able to access the element corresponding. Suppose I want to access this value 3, then how to access it? Simply pass the index of that. So index is 2, so I'm passing 2 here. Okay, so in this way we can access any element of the series. Now let us see how to give the name to the labels. Okay, how to create your own labels in the series. So again, you need to create one series for that. So creating one series, same series again, and here you can mention your indexes or labels what you want. So indexes equal to, I can give any index value, like I want to give the index like 10, 20, 30. So that is also okay here. Then I can so indexes or labels can be anything. It can be a number, it can be a string, it can be name, it can be anything. So you can see here, this time I have given these labels indexes. That's why we are getting these labels. These are called creating your own labels. Now, if I want to give another kind of labels, for example, I don't want to use the number such labels or index, I want to use something name. So I can do that also. Simply I can give the names. Okay, so I can write here Shyam and Sima, like that. So in this case we will have these as a labels. So you can see here labels have been changed. Data is same, but the labels have been changed. This is how we can access we can create our own labels. Now let us see how to access these labels or these data. Suppose I want to access 7. So how can I access that 7? So simply I have to write print s of, and then I have to pass that labels. Okay, whose corresponding data you want to print. I want to print 7, so I will pass sharp. So you can see the output is there. Similarly, if I want to access 3, then I will pass theta. So this is how you can access the series using your named index, or you can say your own labels. Now accessing the item of a series, we have seen this topic, and then now we are going to see how to create a series from a dictionary. So for that, let us first create a dictionary. First create a dictionary. So creating a dictionary, D is equal to day 1, day 2, day 3. So these are what keys. Dictionary has uh, data in the format of key value pair. Okay, so these are nothing but day 1, day 2, day 3 are nothing but keys, and 420, 380, 390, these are nothing but the corresponding values. Okay. So, so this is one key value pair, this is another key value pair, and this is another key value. Okay, so we have here 3 elements in the dictionary. Now just bring this dictionary. After that, let us create a series called my series. My series equal to pd.series. Series function we are using to create the series, and then simply pass your dictionary as a parameter. Then you can, so you can see here we have this dictionary, and the keys of this dictionary are now becomes the labels for the series automatically. So it is very good to create a series from the dictionary, because in series it is expected that we have some labels or indexes along with their values. And dictionary provides both the thing. It provides the data in the form of key and value pairs. So all these keys of dictionary, you can see here, these are the keys of dictionary. They are taken as a labels. They are taken as a labels here. Okay. Suppose if I don't print it, so you'll be able to see that these are the key becomes labels here, and their corresponding values are the values in the series. So creating a series from the dictionary is very good practice. Yeah, it's very good because automatically the keys of the dictionary will be taken as a labels. Okay. Now suppose I have a dictionary, but I don't want to take all the elements of the dictionary in my series. Okay. So how I can do that? So I can select a particular key value pair in my series as per our need. So I will pass simply the name of the dictionary from where I want to include the data, load the data into the series, and then I can simply mention the indexes that I want to include in my series. So suppose I want to include data of day 1, data of day 3, but I don't want to include data of day 2. Okay, so you can see here I have included only keys day 1 and day 3. So only this data and this data will be included into our series. You can see this is not included because we have not included that. So by default it takes all the data from the dictionary, but if you want to extract only few data, a few key value pairs out of the dictionary into your series, then in that case you can mention the indexes that you want to extract from your dictionary. This is how we can simply access key value from the dictionary. Okay. Now let us see how to create a data frame. A pandas data frame is a two-dimensional data structure like a tables. Okay, it's a two-dimensional array. It has some rows and some columns. So let us see how to create a data frame, how to create a two-dimensional array, which is nothing but a data frame, okay, which has rows and columns, and how to create those data frames. So if you want to create the data frames, again you need to first import pandas. So in my case I have already imported it, but still write it again, import pandas as PD. Then you have to create your dictionary. So first let us create some dictionaries. So I'm creating, I'm passing a value here in the dictionary. I'm passing the value 50, 40 and 45. Okay. Then it is closed. Okay. So data is ready now. I want to load this data into the data frame. Okay. So if you want to create a data frame and load this data into the data frame, you can simply write df is equal to pd dot data frame. So there is a function called data frame which you can use to load data into your data frame. Okay. So I'm using that function data frame to create the data frame and simply loading this data into our data. So this is the name of first column, this is the name of second column. Automatically these two becomes columns and this becomes the values in the data frame. Okay, so data frame will look like a two-dimensional table. Okay, two-dimensional array which is nothing but a table. Let me show you that. So let us print this data frame, print df. So here you can see that we have successfully created a data frame in Pandas. So data frame, how it looks like? It looks like a table. Okay, it's like a 2D array. It will have some columns and some rows. Okay. And these are called row indexes. These are called row indexes. Okay, in series, these are called your labels. Here it is called row indexes. Now you can see that data frame is nothing but it is a collection of series. Because if you focus on one column of this data frame, then it is nothing but a series. Nothing but a series. Okay. So data frame can also be called as a collection of multiple series. Okay. And in series we have seen that how a series has the particular what you can say the label. Similarly here also we are having the row indexes that we can refer. Okay. So now let us see how to access the uh, a particular row of the data frame. Okay. So if you want to access any particular row of data frame, you can simply again create a data frame and then you can access it. So it is already created and we have just printed it. Now suppose I want to access the first row, so I will write print df dot log location that we have to use to find out the particular row. Okay, so you can see here I have printed the first row using the location attribute. Okay, so here the location I am providing is 0. Okay, so this will print the first row of the data frame. So here the values of calorie is 420, values 420, duration is 50, duration is 50, and this is the name index. Okay, so name is 0, or you can say the row index is 0. Data type is integer 64-bit in data frame. Okay. Now suppose I want to access the last row 2. So I have to pass the row indexes accordingly. So here I am passing 2. So it will give us calories 390 and duration 45, as you can see in the so this is how we can access a particular row from the data. Now let us create the named indexes in data frame as we did in the series. So here by default the row indexes start from 0. Okay, but if you want to give your own name to these indexes, you can give your own name, that is called as named indexes in data frame. So let me show you that how to give your own name in the data frame for indexes. Okay, so let us take this example and make some changes in it. So here what we need to do, we need to simply mention the indexes that I want in my data frame. So I am just giving them indexes like day1, day2, and day. So this is what I explicitly mentioned, that I want these names as my row indexes. So this will appear as a row indexes. Or so here in place of default indexes 0, 1, 2, it is coming day1, day2. Now let us see how to access the element of the data frame using the named indexes. Using these named indexes. So we can do that easily as we did for what we can say default indexes. Similarly, we can access the element using the named indexes also. So here I am just using the same attribute log location. Now to access the element, you can simply pass the named index. So suppose I want to access this particular row. Okay, so I can simply pass J2 here. Day. You can see here we are getting calories equal to 380 and duration equal to 40. Calories equal to 380 and duration equal to 40. Okay, and name of the your particular row is day2, which is name index. Index is day2. Okay. Data type integer 64. So this is how we can access any data frame, any row of the data frame separately. Suppose you want to access multiple data frame or multiple rows from the data frame, then what you can do, you can mention all those rows that you want to access. Suppose I want to access 2 rows here, so I can mention that So you can see here, whenever you want to access multiple rows simultaneously, then you can simply put them in a list and then pass it into this log. Okay, if you do that, you can get the multiple rows automatically. So day 2 and day 3 data I wanted, so these two particular data will appear into the output. Okay. One thing we have to note down here, that whenever we are accessing a single row, okay, then data is coming in the form of series. Okay, data is coming in the output in the form of series. But whenever you are accessing multiple rows, okay, from the data frame, then data is coming as a separate data frame. Okay. Now let us try to load the files, okay, into data frame, or load data from the CSV file, or let us see how to read a CSV file in Pandas and load data into data frame. Okay, so it is very easy to read CSV file. So simply you can import Pandas as PD, then you create your data frame df equal to pd.read CSV. So we have a function called read CSV for reading the CSV file. Okay, simply if you want to read the JSON files, you have the function read underscore JSON. Okay. So here you have to pass the file name, okay, along with the path where your file existed. So my file, I'm going to use a file which is there in my desktop. I want to use this particular file as a data set. Okay, so let us see the location of this file. So this is what the location of this file. I have to copy the location, and the name of the file is data.cs, and then read data into data frame. So initially we have seen that how to create the data frames from the dictionaries. Okay. Now we are loading the data from the CSV file. Okay, a data set. Suppose we have a data set, okay, in a file called data.csv, and I want to analyze that data set. Okay, I want to do some operation. I want to basically analyze and come to a conclusion from the data set. Then you can simply read that CSV file. Okay. If my data is there in the JSON file, you can also read the JSON file using the function read underscore JSON. Okay. So let us try to run this program. Okay. So as you can see here, we are successfully able to load the data into our data frame. So I had one file, okay, at my desktop whose name is data, and it's a CSV file. Let me show you the content of this file. So you can see here we have duration, pulse, max pulse, and calories. Okay, these are the data available in this file, and it contains a lot of data. Okay, so we have imported that file. Okay, we have imported that file. We have just the file name along with full path name. Okay, so I copied the path of the file from the properties. So this is a file. I have gone to properties. Then here location is given as a file attribute. So I copied this location, okay, and pasted here. Okay, and after that I have given just simply a slash and the name of the file. Then the data is now loaded into data frame. I wanted to see that data, so I converted into string format. Okay, and we have printed the data. By default, whenever you are printing the CSV file, it will show the first 5 rows and the last 5 rows. By default, it will show data in the first 5 rows and last 5. It will not show all the data. However, all the data has been imported into DF data. So this is how we can load a CSV file into data frame. This is how you can read the CSV file in Pandas. Okay. Now let us do some analysis or some operation on this data here which we have loaded just now. You can see the headings has arrived here, duration plus and max plus arrays. Okay. So string is not required here. Without that also we are going to get that. So you can see, okay, and again the default indexes have arrived here 0, 1, 2, 3, 4. So as you can see, first 5 rows and the last 5 rows of our data set have printed here. Okay. Suppose you want to quick overview of data, or you want to view the data quickly, that what is there in your CSV file. So you can use a head function for that. So head function will returns the headers and a specified number of rows starting from the top. For example, if you are using a head function, then you can display the data of what column you want and how many rows you want to see. So that you can mention and get it. Okay, so let me show you that. So I am simply writing here print. In DF we have already imported the data, so I am writing here DF. Yes, I am writing here print and then df dot head. Head function we are using to access the data from this data. So by default it will return the 5 rows if the number of rows is not specified. Okay, otherwise you can specify the number of rows, like how many rows you want. Okay, so let's try that. So this time we have mentioned that we want to see the 10 rows. Okay, so we are getting the 10 rows from 0 to 9. Suppose I want to view the data in the bottom or last rows of the data frame. So for that I can use a tail function. Okay, this showing the first row using the head function. If I want to see the last rows, then I can use tail function. By default, tail function will return last 5 rows. Okay, if you don't provide how many rows you want to see in the output. Okay, so you can use tail function. So you see here last 5 rows for data frame. These are your indexes 164, 165, 166. Okay. Suppose I want to see the last 10 rows for data frame, then I can simply use df.tail and I can pass number of rows we want. So here you can see that last 10 row has arrived here. Okay. So this is how we can analyze the data in the data frame. Okay. You can view the data. You can find from view first 5 rows, last 5 rows, or any number of rows from the top, any number of rows from the bottom, and we can simply analyze it. Similarly, now suppose if I want information about the data, what kind of data is there in particular file or CSV file. So I can simply read the CSV file, and after reading the CSV file, I can simply print the information about the data in the file. So df.info. So info function is used to know about the data in the data frame. So what we did earlier, we imported the CSV file, and we stored there in the CSV file in data frame. We stored the CSV file in data frame, and then now the data is in data frame, and I want to know about this data, what kind of data it is. Okay, I want some information about this data, so I can use info function. Okay. So you can see info function give the detailed information about this data. It is showing that we have four columns. First is duration, second is cost, third is max cost, fourth is calories. Okay, and it is showing that in these particular columns we have 169 entries, and in this particular column we have 164 entries, calories. All the data is of type not null. Okay, the type not null. Okay. And the data type here also mentioned integer 64-bit, integer 64-bit, integer 64-bit, float 64-bit. Okay. So this is how we can know about a particular data, what kind of data is there, how many columns are there. Okay. So this indicates your range. Okay, the data, and for total 169 element is there, so the range index starting from 0 then going up to 168. Okay, it is a data frame. So as you can see, classes pandas dot code dot frame dot data frame. Okay, how much memory it is using, that is also indicated. Okay, so overall it will tell you about everything about the table. Okay, that what kind of data is there, how many columns are there, what column names are there. Okay, in a particular column, how many entries are there, how many values are there. Not null means it is showing that 164 not null values is there. Means 164 values is there. How much memory it is occupying. Every information about the particular data frame will get it. So this is how we can know about the data. Now let us see how to clean the data in Pandas. So now the question is that why do we need to clean the data? So in Pandas, a situation will arrive. They will have a CSV file which is not a cleaned CSV file. It has some problems, like it has empty cells. Okay, blank cells are there. Okay. In this example, you will see calories has 164 entries and rest of the columns have 169 entries. It means that some cells here are blank in calories. Okay, and then data in the wrong format, that can also be there. Okay, wrong format means what, instead of numbers it is showing some strings. Okay, or in other formats. Then we can have unexpected data, like suppose a deviation is a column. Okay, and which has the value in between 0 to 65 or 75, but suddenly we are getting a 500 value there. So that is unexpected data, and that unexpected data is called as wrong data. Okay. So that also needs to be cleaned from the data set, because that may create a problem while analyzing the data. Okay. Then we can have duplicates. Okay. So duplicate of data. Suppose a particular column is unique column and we are getting a duplicate numbers in that. That we need to remove. So we can have duplicate of rows also, like same row is coming twice. Okay, all the same information is repeating twice. So that we can remove. That is called as duplicate data. Okay. So in Pandas, we need to clean the data because of these reasons. We may have the empty cells, we may have data in wrong format, we may have wrong data, which is unexpected data, and we may have the duplicates row. Okay, so if you observe closely our the new file, okay, so we are having a new file called dirty data or bad data. Okay, so we are referring dirty data. So if you refer this dirty data, it has a lot of problem. Okay, so as you can see here, we are taking a new data set here, and in this data set you can see that the column date, so it has a missing value here. It has a missing value here. Similarly, if you see the column calories, it has missing value here. Empty cell is there. So these are nothing but your empty cells. Then we have a date here, which is not in proper format. Okay. We have a date here, it's not in the proper format. And you can see here we have a duration, and if you closely look at the duration, it is maximum 60, and suddenly we are having a value 450. So we have a mix of sample here, okay, to show you that how we can clean the data in Pandas. Okay. So we have some missing value, we have some empty cell, we have some wrong format, we have some unexpected data, wrong data. Okay. So this kind of data is called as wrong data here, 450, unexpected. Then we have empty cells, okay, and then we have data in the wrong format. Suppose the date is here not in the proper format, as you can see. Okay, so these things we need to clean, okay, before analyzing the data. Okay, so for that we need to import this data first. So let us import that data into our data frame. So just change the name of file. Location is same. Location is same, as you can see. This data is also in the desktop where the previous files had. So we can simply import it, okay, and then we can print it. We can simply print it. So we got data here imported, as you can see. Okay, the empty cells will be indicated as a name, not a number. Okay, not a number. Okay. Here the wrong format data is also appearing, as you can see. Okay. So we are able to load this file now, and now let us see how to clean this file. Suppose if I have some empty cells, okay, so what I can do, I can simply remove that particular row, okay, from the data frame. Suppose this is what empty value is there. Okay. Generally, data set contain a lot of data which is of similar type. So if I drop one or two rows from that data set, then that will not create a huge problem. Still we can analyze the data. Okay. So if I'm getting an empty cell here, so I can simply delete this particular row. Okay. So let us try to do that. Okay. Now our DF is holding the data from the new file, which is called dirty data, which contains a bad data. Okay. So we need to clean that dirty data. Okay. So first of all, we try to remove those rows having what we can say empty value. Okay, so just simply delete this row, because deleting one or two rows will not affect our data set a lot. Okay, so for that we can use a function called drop now function. Okay, let me show you that. So we have data frame already created earlier, so simply we can use the data from df. Okay, so df is already having the data. Now we can simply use and write new df is equal to df dot drop now. Okay, then simply use this function to remove the empty, remove those rows who is having empty cells. Okay. By default, the dropdown method will return a new data frame. Okay, and it will not change the original data frame. For example, if you see df is our original data frame and new df is our new data frame. So dropdown function will simply take a copy from this data frame, remove the duplicates, sorry, remove the empty cells. Okay, the cells having empty value. That particular row will be deleted automatically, and the rest of the data will appear into new data frame. Okay. So let me qualify it again. How the dropdown function will work? It will simply copy the data from the data frame df, okay, and then it will remove those rows having empty value, okay, and the result will be kept inside a new data frame. Okay. So in print the new data frame. Okay, so after the new data frame, okay, you can see there is no any nan value, okay, which is called not a number. Okay, earlier we had at 22 we had nan, okay, and here also at 18 we have nan. So let us see at 22 row is not there, it has been removed. See here 18 is also not there, it has been removed. So we have simply deleted the rows having the empty cells, okay, by using dropdown method. Okay. But if you see the original data set, that is unchanged. Okay, that is unchanged. So in the original data set, if you see, we still have a not number, which is empty cell, which is still there. So there is no changes in df. Okay, there is no changes in df, which is original data frame. Only the changes is copied into new df. Okay. So without modifying your original data, we are simply getting the right data or clean data in our hand. Okay, because we don't want it to change the CSV file all the time or data frame all the time. We wanted to keep our data frame as it is, and we wanted the correct output as well. So without disturbing the original data frame, we can get our desired data. Okay, so this is how we clean the data. We clean the empty cells in the data set. Now suppose if I want to make the changes in the original data frame. I want to make the changes in the original data frame. You can use the dropdown method, okay, and you can use a new parameter called in place and mention that. Suppose I want to modify the data, okay, in place only. I want to modify the original data frame, okay. So I can do here. I can simply write here in place equal to true. I can simply write here in place equal to true, and definitely it will what we can say affect your original data frame as well. Okay, so let me show you that. You don't need to write this, simply we can print df here. So as you can see here, I am simply calling a dropdown method on data frame, okay, which has given the new parameter in place equal to true. So when I kept in place equal to true, then it will affect the original data frame on which I am working. So you can see here, this time we don't have any empty cells, okay, in the df as well. Okay, we don't have any empty cell in the df. I'm printing the df original data frame, okay, as you can see that. So if you want to make permanent changes in your data frame, then you can make this in place equal to true. If you don't want to modify your data set, okay, then you just don't use this parameter, okay, or make it as a false. Okay. Now let us see how to replace an empty cell value with some other values. For example, if I don't wanted to delete my rows, okay, I don't want to delete my complete row just because I have one not number value, okay, or you can say I have an empty value here. So just because of the single empty value, I don't want to remove my all of your what you can say uh, row. Then I can simply use the other function called fill any function, which allow us to replace these empty values with some new values, whatever we want. Okay, so I can use fill any function, fill now function, to simply replace the empty cells by a new value as per our choice. Okay, so simply again create one new data frame, and we need to again build our CSV file because we have made changes in the origin data frame. Okay, so we have to create one new data frame here. So this time I am creating a new data frame df1. Let's print that. So we have df1 data frame which has empty cells. You can see here. Okay. Now I don't want to delete the whole row because just because of one empty value there. Okay, I want to keep this row as it is, and I want to put some value here in place of empty value. So I can use fill now method. So how I can do that? Simply I can write df1 dot fill na, and suppose I want to fill this empty value by 9999. Suppose just for example, and write in place equal to true because I want to modify this data frame. So that's why I'm putting in place equal to true. So it will modify this df1 and replace all the NaN value, which is empty value, by 9999. Simply print your data frame. So here we get the output. And see here, all the empty value has been replaced by 9999. So this is how we can bring the empty values in our data set. This is how we can clean the empty values, empty cells in the data set. We have three options. One is simply create a new data frame, okay, by removing the rows which are having the empty cells. Second option is that we can simply uh, make changes in the original data frame and delete that row which is having the empty cells. And third option is that we can simply change the data frame. Okay, we can simply replace the empty value with new value as per our choice and retain the rows, okay, without deleting the rows. In this example, we have seen that how to replace the empty cells values by a new value in all columns. But suppose I don't want to replace uh, all empty cells by the same value. I want to replace a separate column empty cells by separate values. So how I can achieve that? So we can also achieve that, okay, by mentioning the column name whose empty value I want to replace. For example, again we need to load the data frame. So let us first load the data in the data frame and create a new data. So again we have loaded the data from the CSV file. Suppose I want to replace this NaN value with a different value. I want to replace this empty values with some other value, some specific value. But I don't want to make changes in any other column right now. I want to make changes in only this particular column, only this column. Okay, the last column, which is nothing but calories. So if you want to make changes in a specific column, if you want to replace the empty values by a specific value in a specific column, then you can simply mention the column name. So here my data frame name is 1 df1. So I'm writing df1, and you can mention here the name of the column. Okay. So I want to make changes in calories only. So calories dot fill now, and then you can give your desired value by which you want to replace and make in place as true. Okay, and then print it. So here you can see that, okay, only this column has this value. Empty cells has been replaced by 999, but the rest of the columns has not been modified. So you can see that. Now suppose I want to modify date with some other value. Okay, so let me show you that how to do that. So you can simply write df1, and then you can write here date, then you can use fill method, and you can give the new value, whatever value I want. So suppose I want to put here so we can see here we have replaced the uh, empty cell value by a new value. In this example you can see that. Okay, so row number 22 we have to focus. So in the row number 22, earlier we have empty cell value at row number 22. This particular date, see date column is there. Okay. Now after replacing it with a new value, okay, 31st 12 2020. So focus on the row number 22, it has been replaced by. So this is how we can simply replace the empty cells in a particular column, okay, by our new values, whatever values we want to put in. Generally we don't use these new values to replace the empty cells. We use the mean values or median values or mode values to replace these empty cells. Okay. In data analysis, we won't generally replace the empty cells by simply giving a new value. We generally try to replace it by average values, okay, so that we can at least get a correct data for analysis. We get approximate data for analysis. Okay, and that's why we use the mean, median, and mode functions. Okay. So mean function will give you average value, median function will give you the mid value after sorting, and the mode will give you values that appears most frequently in a particular column. Okay. So Panda provides the functions called mean, median, and mode to calculate the average, mid value, and the value that appears most frequently. Okay. So suppose I want to replace the empty cells not by our new number but by using mean, value or median value or mode value. Okay. So how I can do that? Let me show you that. So again we need to load our data into a new data frame. So again let us load the data into new data frame. This time you can give the new name. So I'm writing here to. So again you can see the data frame has been loaded with the empty cells. I wanted to replace this empty value with a mean value. So suppose I wanted to calculate the mean of calories and replace this empty cells by mean value. So at particular row number 18 we have a null number, and here also 28 we have which is the empty cells. So I want to replace this particular values, empty values, with the mean value of the calories column, with average value of the calories column. So I can simply write here df2 or first calculate the mean value x equal to df and calories dot mean. The mean function will give you the mean value. Okay, so just print it. Now we are getting the mean value. Yes, we are getting the mean value. Now let us replace this particular empty value, mean value. So I wanted to replace it in this column, calories. Then I can use Pygame method to replace the empty value, and I can give the new value x. So new value is contained in x, which is a mean value. Okay, so I wanted to replace the empty cells by a mean value. Okay, so mean value is there in the x. That x I am passing here as a parameter in the Pygame method. Okay, and then I can write in place truth. So when so our mean value is 304.68. Okay. So you can see 304.68, and here also 304.68. So you just replace the values with the mean values, the empty cell value and the mean value. Okay. Simply we can use median and mode, just need to change the methods. So in place of mean, you can replace it by median and mode, just have to change this function. If you want to use median, you can simply write median here. If you want to use mode, simply write mode here. Okay. So this is how we clean the data in Pandas. Okay. So let us have a overlook what we have seen till now. Till now we have seen how to import Panda, how to create a series, okay, how to create a series from your list, how to create a series from your dictionary, how to create a series from the list and give your own labels. Then we have seen how to create a series from the dictionary, okay, how to access the element from the series, okay, how to access the element from the series by mentioning our own indexes, okay, the specific indexes, how to load the data into the series by specific indexes, okay. Then we have seen how to create the data frames, okay, from the dictionary, okay, Then we have seen how to access the rows of the data frame, specific rows. Then we have seen how to read the CSV file from a particular location. Okay, how to read the data sets from the location, how to print the first uh, 5 rows or 10 rows of the data frame. Then we have seen how to print the last 5 rows and 10 rows of the data frame. And then we have done a lot of analysis on the data frame, like cleaning the data, observing the data, finding the information in the data frame, like that. So we have done a lot of practice on that. Okay. That's it from my side for Pandas.
There is always an end to every event, and so to this well informed event too. We are glad that you joined us today. Moreover, wish you all happiness, peace, health, success, and liberty in all the fields of life. On behalf of the entire institute, I would like to thank Ms. Pushpa Chatel and Mr. Ratnesh Chaudhary for an enlightening and entertaining presentation of the given topic. We appreciate having this mysterious area clarified. I would also like to thank Dr. S.L. Barjate, Principal of the college, and Mr. Animesh Syal, Head of the Department of Computer Science and Engineering and Information Technology, for pulling out such a great workshop. I would also like to thank coordinator of the workshop, Roshni Talmali. I would also like to thanks to all the teaching and non-teaching staff committee for the complete preparation of this program. We hope that you all enjoyed and learned a lot. I thank you all from the bottom of my heart. Thank you very much to one and all for devoting your precious time and be a part of this event. Thank you all.